So welcome to this session, and today we are going to proceed on to the next chapter, which I had mentioned earlier, and that was area approximation. So in this case, or rather in this chapter, we are going to figure out how to approximate the area under a curve. So the area curve, or rather under a curve, and we are going to use three methods to estimate area. So the first method that you can use is called the trapezium rule. The second method is mid-ordinate rule. And the last method you might need to know is integration. Now, the first two methods are basically going to give us estimates. So the answer you get in the first two methods is basically an estimate of the area under that curve. But you might need to know that mid-ordinate rule is more accurate compared to trapezium rule. And the most accurate, which gives us actually the actual area or the real area, the exact area, is integration. Now please note that we've already done integration. So area under curve using integration method. This one we did under in the previous topic, which was integration. So in this case, we are going to consider trapezium rule and mid-ordinate rule. And without wasting time, let me introduce the first one, which is the trapezium rule. So one thing that is going to be very important here is the formula. Which formula do we use in estimating area using the trapezium rule? You have half of h y1 plus yn, close the brackets, plus 2 into y2, y3, plus y4, all the way to yn minus 1. I will demonstrate shortly what that exactly means. Let's say you have such a curve originating from that point. If this is the value of x, we'll just use the x-axis, and along this line we have the y-axis. So these are basically the corresponding values of y. So we have here y1. In this case, you have y2, you have y3, and y4. So if you are to consider these in the formula, we are basically saying that y1, this is the first value of y, that is y1. yn is the last value of y, yn, so we have y4. So if we are talking about that in the formula, it's 1 over 2 h y1 plus yn is the last value, which is y4, plus 2 into, now you proceed on to y2 as it is here, y2 plus y3. But notice that in this case, our y3 is the last value of y we are going to consider. Why? Because we already considered the last one. So we start with the first one and the last one. Then the middle values of y is what you're going to multiply by 2. So notice that in this case, we are basically saying it's y plus 3. But there is something you will notice here, that this is the second last value, and the second last value is here, which is yn minus 1. So let's see, yn, the value of n is the last value, which is 4. So it's yn 4 minus 1 gives us y3, which corresponds what we have here. So that is how we are getting that formula. So now that we already know what are these values of y, we also need to know how or what is this that we're calling h. So using the same diagram, just sketch another one. So these are basically a trapezia. If you have to look at it in this direction, you will notice that they resemble a trapezia. And h is basically the width of this trapezia. But in most cases, you will not get this diagram. So how do you calculate the value of h? You already know h is basically the width of the trapezia, but you need to know how do you calculate. So h is the number of units over the number of a trapezia, or in most cases we'll talk about strips. So let me get the two: trapezia stroke strips. So the trapezia or strips we are talking about are these. This is a trapezia. This is the third one and the fourth one. So in that case, you'll talk about 4 trapezia or 4 strips. 1, 2, 3, 4. And this is what you call the number of strips. Now the number of units is say, let's say this is 0, 1, 2, 3, 4. So the number of units runs from 0 to 4. So the number of units are 4. So number of units 4 over the number of strips 1, 2, 3, 4 over 4. So the value of h in that case is 1. Maybe let's see how you can apply that formula in practice. So we are told a car starts from rest and its velocity is measured after every second for 6 seconds. So a car starts from rest and its velocity is measured after every second for 6 seconds. Use trapezium rule to calculate the distance covered. So this is a corresponding values of the motion of the object. So we have time, which is in seconds, and the velocity in meters per second. So 0, 1, 2, 3, 4, 5, and 6. So the motion was recorded for 6 seconds. So the initial velocity was 12, then rose to 12, 24, 35, 41, 45, 47. So these resembles the velocity of the object after every 1 second for the first 6 seconds. So we are told to find the distance this object covered using the trapezium rule. Now this is the rule. So we need to figure out, we can already see the corresponding values of y. So velocity is basically the values of y. Because even if you were to draw a velocity time graph, you're going to have in the y-axis, you'll have velocity. in meters per second, and in the x-axis you have time in seconds. So if you were to record that, maybe you'll get such a curve. Actually, it's rising all the way to 47. So starting from a velocity of 0. That is what you would have. So the velocity is basically the corresponding values of y. And time is along the x-axis. So that is what you'd expect. So using the trapezium rule, we already know the values of y, they are here. So one thing that is going to be very important is getting the value of h. So in this case, let me include this using 6 trapezia strips. So the first thing is to get the value of h, and remember we've said h is a number of units. So the number of units over the number of strips. So the number of units starts from 0 to 6. So the number of units is 6. Divide by the number of strips. We've been told using 6 strips. So over 6, that gives us 1. So the value of h is 1. So replace in the formula, you'll have 1 over 2 into h, which is 1, into brackets y1. y1 is 0, plus yn, that is 47, plus 2 into y2, 12, y3, 24, this is a y4, 35, y5, 41, and lastly 45. So you will start by working out the first part. 0 plus 47, that gives us 47. The other part, you add all this, you get 145. This is going to be so you have 145 times 2, that is 190. So you add these two, 47 plus 1 over 2, because 1 over 2 times 1 is 1 over 2. So 1 over 2 into brackets, 190 plus 47, that is 237. So the area is a half of 237, which gives us 1. This is also 1. This is 17, 8, 118.5 square units. So the distance covered by the object is going to be 118.5 square units. And that is how you use the trapezium rule to calculate the distance covered by that object. Maybe we can consider another example. So number 2, we're told estimate the area bounded by the curve y is equals to 1 over 2x squared plus 5. The x-axis the line x is equals to 1 and x is equals to 5, using the trapezium rule, and 5 strips. 5 strips. So in this case, we have the values of x because we are told that the lines x is equals to 1 and x is equals to 5. So that means the range is from x is equals to 1 and x is equals to 5. So the first thing you need to get is the values of y. So you have x1 followed by 2, 3, 4, and 5. Now, we don't have the values of y, but you have the equation. Y is equals to 1 over 2x squared plus 5. So you need to get the values of y. So you have y is equals to 1 over 2x squared plus 5. But you have the values of x, so you replace for the values of x. For example, the first value of y, 1 over 2x. The first value of x is 1. So replace 1 squared plus 5. So that should give you 1 squared is 1. So half of x, that is 0.5 plus 5. That gives us 5.5. So we have the first value of x is 5.5. You do the same thing for the others. Y is equals to a half. The second value of x is 2. So 2 squared plus 5. That should give us 7. And do the same thing for the rest. 9.5, we should get 9.5. The next one we should get 13. And for 5 we should get 17.5. Here, let me change these to 4 strips. Using 4 strips. So the next assignment is to replace in the formula. We have a half of h, but h is the number of units. So from 1 to 5, you have 4 units over the number of strips. So number of units is basically the spaces between them. So you have 1, 2, 3, 4. So 4 units over the number of strips. You're told using 4 strips. So the answer is going to be still going to be 1. So still we have the value of h being 1. So replacing the formula, half h is 1, y1 is 5.5, plus yn 17.5, plus 2 into 7, plus 9.5, plus 13. So we just consider the first one and the last one in the first part, y1 plus yn, then 2 times the rest, the other values which are in between. So 7 plus 9.5 plus 13. So we, in this case, we'll have a half of, this is 17, 22, 23, plus, this is 20, 29.5, that is 29.5, we multiply by 2. That gives us 59. So we have 59 plus 23, that gives us 82. We have a half of 82, which gives us 41 square units. And that is the area of that, or rather under that curve, using the trapezium rule, So one thing that I must mention is, when you're given such a question, you must always ensure that you have the required number of strips. For example, let me erase this part. You're given the numbers from 1 to 5. So you can just write them 1, 2, 3, 4, 5. And I am told using 4 strips. Remember, I mentioned initially that the strips is basically the spaces between these numbers. So you have 1, 2, 3, 4. So you have the required number of strips, which is different from, let's say, for example, you are told to use 8 strips. In that case, we are told to use 8 strips. So notice that when you do this, you have 1, 2, 3, 4, and 5. So when you draw this trapezium, you notice that you have 4 strips, but the question says using 8 strips. So how do we get the 8 strips? How do we get the 8 strips? So it's a very straightforward mathematics here, because you will notice if you have 4 and you need 8, then you need to divide each one of them by 2, or rather multiply each one of them by 2. So you divide this by 2. Each strip, initially they were 4. When you divide them by 2, you get 1, 2, 3, 4, 5, 6, 7, 8. Now you have the required number of strips. So you will notice that this strip will correspond to the value of x as 0.5. 1.5. This one 2.5. This one 3.5. This one 4.5. And so in that case, your values of x will not be 1, 2, 3, 4, 5, but instead 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and lastly 5. These are going to be the new values of x in the event you're told using 8 strips. So you need to first of all ensure that you have the required number of strips. Ensure that you have the required number of strips. How about if we are told to use 2 strips? So again, not 8 but 2. So you have 1, 2, 3, and 4. Sorry, and 5. We have 5 also. So if you're told to use 2 strips, notice that you have 1, 2, 3, 4. You have 4 strips, but the question requires that you use 2 strips, not 4. So if you have 4 and you need 2, so what do we do? In that case, you merge 2 in groups of 2. So we are going to merge them 1 to 3, then 3 to 4. So you're going to end up with 1, 3, and 5. 1, 3, and 5. Because this one is merged to form 1. These 2 are merged to form 1. So you're going to end up with 1, 3, and 5. So your y1 will be the, so in that case, your new values of x will be 1, 3, and 5. Y will be the corresponding values of y. We have them here. We have for 1 it was 5.5, 3 9.5, and 5 17.5. So your y1 will be 5.5, yn 17.5. So you'll only work with and before that, maybe we can get h. In that case will be the number of units, which are 4, divided by the number of strips. We are told to use 2, so the value of h will be 2. So you have a half of h, which is 2. y1 is 5.5 plus yn 17.5 plus 2 into the remaining, and the remaining in this case is just 9.5 times 9.5. That gives you the area. So by now you should be able to solve this part. You start with this part, followed by this one. You add the 2, then multiply by the result of a half of h to get the answer. And that is what we need to know in as far as the area approximation using the trapezium rule is concerned. One thing, the formula, very important. Know how to get the value of h, and also know how to maneuver that formula to get the correct answer. Another thing that is very important is the number of strips. So if you're given such a question, the first thing we need to do is to ensure that we have identified the required number of strips. That is the first thing you need to do. You need 4 and you have 2, you divide them into 2 you divide each strip into two parts. You will have 8 and you need to use 4, you merge them in groups of 2 to end up with the required number of strips. And with that, you can now proceed on to the next one. Which is the mid-ordinate rule. So even in this case, the formula will be very important. So using the mid-ordinate rule, this will be the formula. This one is easier or easy to remember compared to the trapezium rule. You have y1 h into y1 plus y2 plus y3 plus y4 all the way to yn. That is the formula. So of getting area using the mid-ordinate rule. And again, h is still got it the same way as in the other case of the trapezium rule. H is the number of units over the number of strips. The only thing that is different in this case are the values of y. So if you have such a curve, so you are told using 5 strips. Just like I've said in the other case, the first thing is to make sure you have the required number of strips. So if you're told using 5 strips, make sure that you have 5 strips. So in this case, I have 1, 2, 3, 4, 5 strips. So after getting the values of the required number of strips, you need to identify these values of y. But in this case, these values of y are not the same as in the case of the trapezium rule. From even the name itself, mid-ordinate, mid. You see, in this case, these strips can also be called, not the strips, but these lines are called ordinates in the mid-ordinate rule. So if you are told to get mid-ordinate, so these lines here, these ones are called ordinates. So in this case, I have 6 ordinates. So mid-ordinate rule means that you get the midpoints of the ordinates. So the midpoint of this ordinate is somewhere at the middle of this bar or strip. So in this case, you will use these values here, the corresponding values of y of the midpoint, the corresponding values of y of the midpoint of each bar. That's this one. And the last one here. So you must identify the midpoint of those bars first. So that will be the values of y. Those are the values of y we are going to use, not these ones as it was in the case of the trapezium rule. Maybe we can see an example and see how exactly we are supposed to apply that. So we are told, example 1, estimate the area bounded by the curve y is equals to 1 over 2x squared plus 1. The line x is equals to 0. X is equals to 3. And the x-axis using mid-ordinate rule. And the 3 strips. And 3 strips. So in this case, notice again that we already have the values of x. So we need to find the values of y. So look at this. I have just said 1, you need to identify or get the required number of strips 0, 1, 2, and 3. Let's see how many strips these ones are going to give us. We have 1, 2, 3, 3 strips. And the question requires us that we use 3 strips. Now, see, we are not going to use 0, 1, 2, and 3 as the values of x, because this is a mid-ordinate rule, not the trapezium rule. So after getting the required number of strips in the mid-ordinate rule, we need to locate the midpoint of each strip. Look at what we did here. You locate the midpoint of each strip. So the first strip is from 0 to 1. The midpoint will be at 0.5. 0 plus 1 divided by 2. So 0 plus 1 is 1 divided by 2, you have 0.5. 1 plus 2, you have 3. Divided by 2, you have 1.5. And 2 plus 3 is 5 divided by 2, you have 2.5. And in that case, these are going to be the values of x. So these are the values of x. So from there is that you will now be required to get the values of y. And you already have the equation. Y is equals to half x squared plus 1. The first value of x is 0.5. So y is equals to 1 over 2 into 0.5 squared plus 1. In that case, the answer should be 1.125. So replace here 1.125. You do the same thing for 1.5 squared plus 1. The answer is 2.125. You write it here, 2.125. You'll do the same thing for 2.5, and the answer is 4.125. Then from there, you now replace in the formula h into, what is the value of h? H, the formula is the same as in the trapezium rule, number of units over the number of strips. So the number of units from 0 to 3 is 3 over the number of strips you're told to use 3. So h is 1. So you have h using the formula h into y1. So 1 into y1, 1.125 plus 2.125 plus 4.125. Just add that multiply by the value of h, and the answer is 7.375 square units. And that is how you're supposed to use the mid-ordinate rule in that case. How about if we are told to use 6 strips and not 3, like it is in this case? Let's say, for example, you have you're told x is equals to 0 and x is equals to 3, like it is in this case. So using 6 strips, let's see, you have 0, 1, 2, and 3. So we have noticed that in that case, like we've done on the other side, this gives us 3 strips. So we need to get 6 strips. So in this case, using 6 strips. So in that case, we'll divide each strip by 2 because we need to get 6 strips. I have just said that the first thing that you need to make sure that you do is to make sure you get the required number of strips. So this becomes 0.5, 1.5, and 2.5. But again, you cannot use 0.5, 1.5, 2.5 as the mid-ordinates, because we've only done this to get the required number of strips, 6. So after getting the required number of strips, you now find the midpoint of each strip. So you will proceed further and find the midpoint of each strip. and that will now give you the values of x, which you use to get the corresponding values of y. So 1, get the required number of strips. You're told to use 6. You have 0, 1, 2, and 3. That gives you 3 strips. But the question, use 6. So divide each strip by 2 to get the required number. 1, 2, 3, 4, 5, and 6. You have 6 strips, but you're using the mid-ordinate rule. And the mid-ordinate rule requires that you get the midpoint of each strip. So after getting the required number of strips, now find the midpoint of each strip. Like in this case, you would need to do 0 plus 0.5. Then you divide that by 2 to get 0.25. That becomes your midpoint. That becomes your new midpoint. The same thing, you proceed on the next part. You have 0.5 plus 1, that gives you 1.5. You need to divide that further by 2 to get 1.75. Do the same thing for the next one. 1 plus 1.5, you get 2.5. You divide by 2, that should give you 2.25. You have 1.5 again plus 2, you have a 3. 3.5 divided by 2, that should give you, I think, 2.75, etc. Make sure you first of all get the required number of strips. After doing that, you now find the midpoint of each strip. That is the first thing you must do. Let's say you have another example here. You're told x is equals to 0 and x is equals to, say, 8. And you're told to use 4 strips. Let's see what happens in such a case. So you have 0, 1, 2, 3, 4, 5, 6, 7, and 8. So notice that in this case you have 8 strips. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 strips, but you're told to use 4 strips. Using mid-ordinate rule and 4 strips, estimate the area bounded by this curve and the lines x is equals to 0 and x is equals to 8. Now in this case, when you do this, you notice you have 8 strips, but the question requires that you use 8. So in this case, unlike in the previous case where the number of strips was half the required, in this case the number of strips is twice the required. So what we do in this case is the same as what we did in the trapezium rule. You merge in pairs of, or in groups of 2. So we merge the first 2 strips to form 1. So from 0 to 2, that will form 1 strip. Then from 2 to 4, 2 to 4 forms the second, 4 to 6, then 6 to 8. So in this case, you notice that you now have 1, 2, 3, and 4. You have 4 strips. Now, I have just said, after the first thing, get the required number of strips. After getting the required number of strips, you now find the midpoint of each strip. So the first strip runs from 0 to 2, and its midpoint in that case will be 0 plus 2 divided by 2. So 0 plus 2 is 2 divided by 2, you get 1. So the midpoint will be 1. And thus, this now forms the values of x we will use. So the first value of x is 1. The next one is 1. 1 runs from 1 to 3. So 1 plus 3 is 4 divided by 2, you get 2. So this one will have 2. Then we have the next one running from 3 to 5. That is 8 divided by 2, 4. We have the next one running from this is 5. 5, 0 to 3, 2 to 4, 4 to 6, 6 to 8. So we have 6 plus 8, 14, divided by 2, we have 7. Sorry, we still have 4 to 6 first. 4 plus 6, 10, divided by 2, 5. And lastly, 6 plus 8, 14, divided by 2, 7. Then from there, you now find the corresponding values of x, y. 1, 2, we have 1, 3, not 4. We have 1, 3, 5, and 7. That is 0, 2, you have 1. 1, 3, not 1, 3, but 2, 4, 3. because we have the next one running from 2 to 4. Then we have 4, 6, 5. We have 6, 8, 7. Those are the values of x. Now find the corresponding values of y and replace in the formula. Notice that in this case the value of h will be number of units from 0 to 8. You have 8 divided by the number of strips you are told to use 4, so over 4. Again, the value of h in that case will be 2. And that is how you're supposed to use the mid-ordinate rule in estimating area. Notice that, recall rather, that I said a mid-ordinate rule is more accurate compared to the trapezium rule. So in the hierarchy of accuracy, the first one, or the most accurate, or the formula that gives us actual area is integration. Number 2 is mid-ordinate. And number 3 is a trapezium. So the trapezium rule is the least accurate method of estimating area. Integration gives us the actual area. And remember, we already did this in the trapezium rule. For instance, in this case, if you are to use the integration method to calculate the area bounded by this curve, y is equals to x squared. So use integration, 1 over 2 x squared plus 1 with respect to x. So you're told the value of x is 0 and the other value of x is 3. So the lower limit in that case will be 0. The upper limit is 3. Now integrate 1 over 2 x squared. Now notice how we are going to integrate this. 1 over 2 x to power 2. We say the integration, you add 1, then you divide by the result. Divide by 3 plus 1. If it's a constant, that means its value of x was to power 0. So we add 1, divide by the result, which is going to be 1, plus a constant c. By now, I am sure you still recall how to integrate. So the lower limit is 0, the upper limit is 3. Now in this case, notice that if you divide by 3, then we are going to have 2 times 3 in the denominator. So you're going to have 1 over 6 x cubed plus x plus c. Lower limit 0, upper limit is 3. So 1 over 6, 3 cubed plus x, which is 3, plus c, minus 1 over 3, 1 over 6, 0 to power 3, plus 0 plus c. So it's the same thing that you are doing in integration. So take note of this part, whereby you're integrating a fractional or decimal fractions. If you had a 1 over 4 x to power 2, you're integrating that, then you're going to have 1 over 4 x to power 3 over 3. So in that case, the answer will be 1 over 12 x cubed. That is very important. You need to know how to integrate that. And those are the 3 methods you need to know in area approximation: the trapezium rule, mid-ordinate, and integration. So with that, having understood the formulas and how to get the number or the required number of strips and how to apply those formulas, you should be able to do as many questions as possible in the 2 or 3 areas. I am sure you've done as much in integration as since we've already done the topic integration. So the next thing that you need to do, familiarize yourself with all the 2 formulas. Get as many questions from your book, solving problems. You should be able to get as many questions as possible. Do them, and with that, we shall be good to go. So until next time, keep doing as many questions as possible in this topic as we prepare for the next topic. So far, we've covered, I think, 4. So we still have 2 more, which we're still going to do in the course of this week. So let's look forward for the next session, maybe tomorrow or Tuesday. So until next time, let's purpose to do more questions or as many questions as possible in this topic. In case you have any question, you know what to do, as we had discussed earlier. Just ask your questions in the comment section. We will respond to them as soon as we can. I want to thank you for participating and cooperating in these sessions.